So far, we have covered so many different solids and seen their surface areas and volumes. We will cover one last solid in this video series and also try to derive the formula for its surface area and volume. This is quite an interesting solid, and examples on this solid are not quite easy to solve. So, are you ready? The solid for our topic today is this one. It's called a frustum of a cone. It's obtained by slicing a cone. Let us see how. Suppose we have a cone here. We cut this cone by a plane which is parallel to the base of a cone in this way. What do we get? We get two solids. One of them is a cone again, but with a smaller radius and height. The other solid we get is this one. It's a frustum of a cone. What surfaces is it made up of? We see that it has two non-congruent circles as its two bases. It also has this curved surface. Can you guess then what will be its total surface area? Its total surface area will be the area of the curved surface plus area of this circular base 1 plus area of this circular base 2. Now I'm pretty sure you will be able to find the areas of these two circular bases. But what about the curved surface area of the frustum? Can you think of a way to find that out? To find the curved surface area of the frustum, let's use an interesting technique. We rejoin this smaller cone with our frustum. Note that this small cone is not a part of our frustum. We did this because it will help us derive its curved surface area in the simplest way. To avoid confusion, let me shade the frustum. It is this shaded area we are interested in. Let's see how this technique of adding the little cone back helps us. Let R1, H1, L1 be the radius, height and slant height of this entire big cone. Let R2, H2 and L2 be the radius, height and slant height of the smaller cone, and finally let H and L be the height and slant height of the frustum. From this figure, we see that the curved surface area of the shaded region is equal to the curved surface area of the bigger cone minus the curved surface area of the smaller cone. The curved surface area of the bigger cone is pi r1 L1 and that of the smaller cone is pi r2 L2. This is the curved surface area of the frustum. We still need to find the area of these two circular bases. We see that the area of the bigger circle, that is base 1, is equal to pi r1 squared. And similarly, the surface area of base 2, that is the smaller circle, is equal to pi r2 squared. So total surface area of the frustum will be this. Now can you try finding the volume of the frustum of this cone? Try it out. Compared to the surface area, it's pretty easy to find its volume. Its volume will be the volume of the bigger cone minus the volume of the smaller cone. What is the volume of the bigger cone? It will be equal to 1 over 3 times pi r1 squared h1. And what about the smaller cone? It will be 1 over 3 times pi r2 squared h2. That's the formula for the volume of the frustum of a cone. But do you notice something interesting? You must have noticed that we haven't really used the parameters L and H in our formulae. Yes, we haven't used the slant height and height of the frustum of the cone. Does it mean that we don't need them when we're solving examples? We'll see that in the next lesson.